Welcome everyone. This is Jay Reister with Seiler Geospatial Mapping Team. Today we are having a webinar with our business partners, LaserTech. And today's topic is going to be collecting accurate positions with lasers on remote assets and using GNSS in a combination. And we'll go through different workflows from the LaserTech side, from the Esri side, and also the Trimble side. Again, my name is Jay Reister, Senior GIS Application Specialist with Seiler Geospatial. And with me here is the team from LaserTech, and I'll let Derek and his staff introduce themselves.
Hey, thanks a lot, Jay. Appreciate being here and discussing everything. So my name is Derek Rash. I'm the Global Manager of Product Management. I've been with LaserTech over 25 years, working in the Professional Measurement Division.
This is Steve Colburn with LaserTech. Like Jay, I'm an application specialist for the company. I've been here for over 30 years and know the products real well.
My name is Jay Cottrell. I am the Senior Global Marketing Manager here at LaserTech, and we put together all the materials that help give you resources and support you in your journey.
All right. Thank you, everyone, for joining us. So quick summary of what we're going to cover today. Basically, we want ease of use, safety, more or less, map more, move less. We'll cover what LaserGIS from LaserTech has to offer with their laser measurement products and software. And then, of course, any outcomes that some of you have already experienced in the field, best practices, and how to collect remote assets with GNSS. Quick little introduction to the Blue Shirt Brigade, as we call it. This was a slide last year at our training in Trimble back in April, and we've got some more blue shirts to add to the squad here pretty soon too. So the region that Seiler Geospatial includes with survey, mapping, construction, drones, and Autodesk and Esri, as you can see here from the Midwest along the Mississippi River. Recently, NEI from the South, Arkansas, Mississippi, and Louisiana. Some of the staff and or customers from that region may be on the call too.
Thanks, Jay. Just a little bit about LaserTech. We've been Seiler Geospatial has been a business partner of LaserTech for over 20 years. They've been supporting and reselling our products. What about LaserTech? We're located here in Denver, Colorado. We manufacture, design, and distribute laser rangefinders that can measure distances and also that can measure speed. We use a pulse laser technology or reflectorless technology. Again, we develop everything here in-house and deliver it to our partners such as Seiler. More about just what a laser rangefinder is. Just kind of talk about laser 101. It's a non-contact remote measurement device. So you can get different measurement values to all different types of objects. So there's no safety gears needed, no height poles when you're taking measurements or anything like that. And it's a one-person operation. So you can just be one person in the field. You don't have to have another person holding a pole or a reflector to get these measurement values. And the other thing is with this instrument, you get these instant results or all those measurement values right in the field. Also, you can download it into different apps, and we're going to talk about that here shortly. So what does that look like? Just different sensors that we have built in the laser rangefinders. We've got our laser sensor that does the distance and range to different objects, almost any type of object that you can measure to. We have a tilt sensor. With that, it's measuring the tilt of the unit or the inclination of the unit based on gravity. And you can see there plus or minus 90 degrees. In another laser we have a compass sensor built in. With that compass sensor working off magnetic north, we'll be able to get our different azimuth values. We also have a modular device that we can use. It has an angle sensor. This modular device can be integrated or incorporated with these laser rangefinders, and with this device, we're able to measure horizontal angles down to about 1/10 of a degree. What's that actually look like? for a couple diagrams. So with the press of the fire button on the laser rangefinder, the laser sensor and also the tilt sensor, they measure at that same time. They take the values. And you can see there, we get our slope distance, or line of sight distance sometimes called, and our inclination value. And with those two different values, the unit automatically calculates that VD, or vertical distance value, and also horizontal distance, HD value. If you have a laser that has a compass sensor, this is where we're going to get our azimuth. And again, it's press the fire button, you get all these different measurement values. They're measured, and then you get the calculated values also. And you can scroll through the screens to see the different values that are being measured and also captured. Along with just taking distance measurements, we actually have different measurement routines built on board. So to collect more data as you're out in the field, there are applications where you want to get a height measurement and have that part of your asset collection. So with this height measurement, we have what we call a 3-point height mode. The first thing you want to do is you take your first shot to the object, and now that doesn't have to be exactly horizontal. It doesn't have to be exactly horizontal. You can take a measurement on anywhere on the object, and the laser will calculate that horizontal distance. Then from there, we're going to do an inclination shot to the base, and then an inclination shot to the top. And with those three values, the instrument automatically calculates a height measurement. With the shot 2 and shot 3, it is just the inclinometer, and the laser is not firing. So if there's brush on the base of the pole or anything like that, you're able to still get an inclination value to be used for that calculation. Another routine that's used commonly is what we call missing line routine. This is where you're going to take actually two laser measurement values to the target. You're going to do like a shot 1 to the base and a shot 2 to the top. And then if you wanted to know that height of that object or anything like that, or like a conductor hanging over a roadway, you'd scroll till you see that VD value, and that gives you your height measurement. You can see all the other different values up in the right-hand corner in that diagram that the solution will actually give you too. Like if you're taking a measurement at the top of a hill and you want to know the slope distance of that hill or inclination from shot 1 to shot 2, you're able to do that. So all those values there in the black dotted line, those are what's being calculated based on your shot 1 and shot 2 values. When we incorporate a compass into the laser rangefinder, this is where we can do a 3D missing line routine, or get a span of an object. So you take shot 1 to your left, and shot 2 to your right, and based again on those values that the laser is capturing or measuring, we're able to auto-calculate all these different values you see here. You can see that span, the horizontal distance value, your slope distance from shot 1 to shot 2. So if shot 1 is higher up than shot 2, you can also get that vertical distance value. So it's very powerful, especially when you're standing on a roadway, standing in a nice safe location, and you're taking all these different measurements that you can get all these calculations. And these values do output, like we'll talk about, into some different apps to capture that for your field data collections. I'm gonna do a little, get more of the product line of all the different models. And then we're also gonna talk about the couple different apps we have, and then get into some different applications. So we released the new models here, the TruPulse 200i, 360i over the last year. And that's our flagship products. And here are some key features of these lasers. Our performance range, you can see here, our distance accuracy. We've increased our distance accuracy from our previous models, and our inclination accuracy has also increased. So we've done a lot of different research from our legacy models to these new ones that we've came out with. And then all the same thing with our azimuth accuracy. We're still maintaining a plus or minus a degree with the azimuth values. Some other key features. This does have wireless connectivity. We have a dual mode chip in it that has BLE and BT Classic. So it can integrate or connect to all different smart devices, iOS, Android, and Windows. And we didn't change anything with our output methods or anything like that. So if people have apps or software they've developed in the past with our legacy models, it is still the same output that you're going to get here with these different models. We continued with our true targeting feature to help you, utilize laser in different methods, different modes, and also the true targeting also gives you confidence that you're getting the target. We have a visual and also a feedback on the laser, so you know you've captured the or you measured to the right target. The unit is waterproof, IP67, so you can drop it in the water. Still is able to use. Very ruggedized unit, like some previous models we've had. Another one we've got is what we've improved on is the display. We've got an ultra bright display, and so if you're utilizing it like in a bluebird day, like in Colorado, and you're looking up in the sky, you're still able to see the whole display. It does not wash out with the sunlight. So we've improved on the display on this on the TruPulse 200i and also on the 360i. Another model we've got is called the TruPulse L2. This is our entry-level laser rangefinder. It does have different accuracies versus the 200i and the 360i. This unit does not have wireless communications. So again, but you're able to still do all those different measurement routines I discussed with the height measurements, 2D missing line, and get all your different values of slope distance and horizontal distance. This unit is a 2D rangefinder. It does not have the compass built in. So again, it's our entry level model here. Another legacy product we've had, I've carried with probably one of our most accurate instruments is the TruPulse 200X. You can see the distance accuracy is down to plus or minus 4 centimeters. This unit is also waterproof. It can handle all different types of conditions, and this does have a wireless communication where you again communicate with all different types of iOS devices, Windows or Android operating systems. So there's a lot of different choices with our laser rangefinders for your needs, definitely for your accuracy needs, etc. I'll talk about just some supporting products that go along with our laser rangefinders. One is I talked about is called this MapStar TruAngle 2. What it does is it precisely calculates a turned horizontal angle. That's using the angle sensor. Now this unit is not affected by local magnetic interferences like a TruPulse 360 could be, since it's using the TruPulse 360 uses a magnetic sensor for the compass and can be affected by local magnetic interferences that we'll talk about here shortly. But if you're working in a lot of construction zones, etc., but you still need the 3D measurements, this is what you would use a laser rangefinder, and then also with this MapStar TruAngle. This does have Bluetooth communications, BLE, so it can communicate with iOS and Android. Very easy to use, simplified buttons on it. There's no display. It's just turn it on and you start getting your horizontal angles. And it also is it's waterproof and ruggedized with the aluminum machine housing. Some other key features on it is just the accuracy. What we do is we want to make sure you're maintaining your accuracy, and we're doing a level assist 8 alert. So if you tilt the unit too far, it will not measure the angle at that point. So we're protecting the end users to make sure they're maintaining the accuracy that's needed. Talked about the integration with all different types of TruPulse models, and it's got kind of a modular design, so you can do a lot of different setups with it. We've got different brackets. You can put the laser right above the unit itself. You can put it in line with the GPS pole. If you have a split 2-meter pole, you can put it in line with that. So everything is in one area where you get your receiver on the top, laser rangefinder on the side, and then Then you've got another way of putting it on like a survey tripod. I'm going to let Steve talk more about the LaserSoft apps that we've created.
All right, thanks, Derek. The first one I'd like to discuss we call Measure 2, and it's just kind of a catch-all data collection app. Not necessarily for GIS data collection. It could be for anything. People out capturing height and missing line values, like Derek was mentioning, or it does have a GPS offset capability in it, so you can grab some of those. But it'll just communicate with all our laser products, allow you to create a project and collect a bunch of measurements. You can add notes to them and images and things like that. And then you can see we've got some simple data output formats at the end there. Nothing fancy. You could go into a GIS, but certainly capable of doing some reporting with it. So that's the Measure 2 app, available for both Android and iOS, and just kind of a generic catch-all data collection app for you. Next, we have LaserSoft Connect, which we've written as a companion app to Esri's ArcGIS FieldMaps. Some of you may be using FieldMaps to collect your GIS data out there with your Trimble receivers, and the Connect app will allow you to perform point offsets. You go to start to log a point, you can offset that location. It'll automatically pull up the Connect app here and allow you to use several different methods to collect that position. And I'll discuss those here coming up, but it'll also allow you to include those height and missing line measurements that Derek mentioned earlier. Great things to get out of the laser. Okay. So here's the basic concept of a laser offset. You have a remote target or asset or whatever it might be over there, and you need to locate it. You need to put it on your map, but you don't want to take the time to rent a boat and cross the waters here, or drive around, or whatever it might be. Maybe this is a busy roadway or something in between you and the target. So the idea is to get your location for where you're standing, nice open view of the sky. You can get a good accurate inclination, possibly, and by using these workflows we have, you can put that object on your map without having to visit it. So as we've kind of mentioned, time savings, safety, that kind of thing. So here's some of the environmental conditions that kind of lead you down the path to needing to collect offsets. You've got limited access to the GNSS. You're down in an urban canyon where you've got impaired by the sky and everything. You can stand off where it's open and measure down into those areas. Inaccessible terrain, real steep, nasty terrain. You can avoid that by just shooting to the objects directly. Or maybe it's dangerous areas. You've got furniture assets out in the street that you need to measure. You don't want to take the time to shut down traffic. You can get the locations that way. So here's the first workflow that we developed for performing these offsets. It's the easiest one. It uses the TruPulse 360 models, the 360i, for example, with the electronic compass. And it's kind of that basic picture that we showed at the beginning there. You stand at one location, grab your point, and then measure to the object. You're going to measure distance and azimuth, and you can put it on your map that way. So real quick and easy to do. It's great for a bunch of different features. If you can even increase productivity this way. If you've got 10 objects, easy way to do the offset. However, it is a compass. If you could advance to the next slide, compass is a compass, right? It's nothing magic. It's still going to be deflected by local distortions to the magnetic field caused by large iron objects or things like that. Keeping a minimum distance to them and so forth. We've got a complete chart that lines out a bunch of different objects that you might run into out in the field and the minimum distance to keep away from them. It's doable, but you've just got to keep your wits about you and make sure you're in a safe spot. So the next slide. Talk about calibrating the compass. We have that ability in there too. The compass, as the batteries deteriorate or as you move locations or something like that, that compass calibration you did last week just may not be good this week for the job at hand. So we indicate to the user a compass calibration is needed by flashing a check mark on the screen. It's real obvious, it catches your eye, and then you know what to do. So as I mentioned, it can happen when the batteries drain, if you have a large temperature swing during the day, if you move your location a long ways, it's always a good idea to calibrate in that local magnetic field. So it's a real simple process, just takes a minute, you get a pass indication, and then you're good to go. Okay, so just be aware when you're out there. You want to make sure you don't have anything on your person, metallic objects, eyeglasses, rings, your cell phone up close to the laser, something like that. The equipment, you've got to get your GPS antenna, and maybe it's got a battery in it. You've got to get that a distance away. Your data collector, your tablet or something, make sure that's a good distance away. And then you can't map in your truck. Unfortunately, with the compass, you've got to get out away from it at buildings and things like that. So we've got some good guidelines. They're easy to follow, and it's a real efficient way to map. So the next method that we're going to discuss is called distance. And this is kind of an intersection of the two distances. So here you've got an object that, again, is remote, it's inaccessible, something like that. You don't have a compass module. Maybe you're in an environment where the compass is going to be ineffective. Any one of our 200 model lasers can utilize this method. So you stand in one location where you've got clear line of sight to the target, you measure to it, grab your GPS location and measure to it, and then you move to another location, down the sidewalk, down the street a little ways, where you can again grab a good GPS location and then see back into the target and measure to it. You do want to have some geometry considerations here. You don't want to, shoot 50 feet into a target and then walk 5 feet with the GPS and then shoot again. You want to space the GPS points out a little bit. Create an equal-sided triangle with everything if you can. That'll give you the best results, most accurate results. But it is a very accurate method based just on the accuracy of the distances. That's all you're really working with. So not great for densely populated objects. A feature here or there because you've got to take those 2 GPS points, but can be a real accurate way to position objects. And then lastly, we'll talk about the distance-angle method, which uses that angle encoder accessory that Derek told you about, where again, you can bring any one of our lasers and even a 360 and connect it up to that TruAngle, and now you've got super accurate horizontal angles you can turn to all your offsets. So put us back in that situation. Now you're in an urban setting where you just can't trust the compass. The workflow is to set a backside point somewhere to reference that encoder to, so it kind of knows where it is on the circle. So you set that reference point, then you go occupy your point where you're going to measure from. You reference the encoder to that backside point, and then you spin around and start measuring to your features. So from then, it's just a single shot out to your features to put them on the map. And again, a super accurate way to do it. So those are the 3 basic workflows that we have in the Connect app to do your laser offsets. And here's a quick table that just can kind of give you an idea of your final position accuracy based on the laser alone. Remember that you've got to add your GNSS accuracy tolerance to these values to get your overall tolerance. But these are kind of the accuracies, errors that are possible with the different methods. You can see the distance method, super accurate there. Some of the applications then, street light, urban forestry inventory, great application for the laser. You've got a nice upright object you can measure to with the laser. usually densely populated, so a real efficient way to collect everything. We talked about that, you know, the manholes and other assets out in the middle of the streets, another great application for it. So yeah, anywhere where you've just want to increase your efficiency, or you've got some features you want to map that are just a little out of reach or unsafe to occupy, great application for laser offsets.
All right, Steve. Thank you, Derek, too. Steve, quick highlight, though, or something to mention. For the 360i, do you recommend putting the magnetic declination directly into the unit or into the app?
Right. Thanks for reminding me. We had that in a little bit of the text there. That's an important consideration to do. There is this value of declination that you apply to compass readings to correct it to true north. The magnetic North Pole, unfortunately, is not at the geographic North Pole. It kind of drifts around. So you have to apply this declination to correct it to true north, so that when you're putting on your maps with other objects you've mapped with GPS and stuff like that, everything will line up. So with the Connect app into FieldMaps, you want to make sure the declination is entered into the laser. You put it into the laser, you get an indication it's applied, and then you're good to go. Thanks, Jay.
Yep, and I think that's in the user guide. I'm not sure if it's in your professional videos that Derek has done, but we can put that in the chat too, if what page it might be on the 360 user guide. I'll talk a little bit about that too when I get into the TerraFlex side of things. So I'm going to talk a little bit about using the Trimble GNSS products with every software that both Derek and Steve just talked about, and in addition to with Trimble TerraFlex. All right, so some of you may be familiar with some of the products on the screen here. On the right is the TruPulses, the 200i and the 360i, their new generation that came out 2 years ago. To the left of that is the R2 and our R580, different varieties of accuracy, sub-meter, sub-foot, centimeter, and then to the left of that is our Trimble DA2 Catalyst, which has 4 different accuracies based off of a subscription. And then on the left-hand side is our ruggedized Android phone, the TDC6. And again, in conjunction, these will all work with the Measure 2, MapSmart, Connect app for ArcGIS FieldMaps, and then also to TerraFlex and Trimble Mobile Manager, which we'll discuss in the upcoming slides. Again, just reiterating, LaserSoft MapSmart does work with our R series, R2, R580s, Catalyst GNSS subscriptions of accuracies of 60 centimeters, 30 centimeters, 10 centimeters, and 1 centimeter. The TDC6 does have its own internal GNSS, but that's around accuracy around 1.5 to 2 meters if you did go standalone with its GNSS. And then doing offsets, of course, we just talked about this with Steve, talking about his applications and use case scenarios, whether it was environmental conditions and or applications itself. Basically, the 200i and the 360i are the go-to, the latest models. The 360, of course, the older models do work with TerraFlex, and also so does the 200X. But again, Steve did mention that the 360 is the compass calibration routine. If you're using any of the 200s, you then do have to do the 2-point offset or distance. All are great workflows. It just depends on the right tool for the right job and what conditions you actually are in at that time, whether it's urban canyon or wide open conditions or underneath tree canopies. All right, so the problem that the customer faces, and Steve did discuss this, is you've got a busy street, or you may have a river or a ravine in the way. It's going to take you too long to maybe shut down that infrastructure. It's time consuming. It's hazardous. You don't want to cross that river in waders or a john boat, or have to drive all the way around to get to the other side. So if a laser application for offsets can be used with GNSS, then basically it's the right tool for the right job. A lot of users that use GNSS or traditional GPS, back in the day when we only had GPS signals and not the other constellations that we now have of Galileo, Beidou, and GLONASS, it was tough to get a GNSS location or lock underneath the tree canopy. So one of those suggestions then is doing a manual offset or a laser offset. And so we have a variety of customers, whether they're in public works, public park utilities, forestry utilities, have found this application using laser offsets with GNSS combination a very valuable tool. That way too, you can also maintain that high accuracy that you purchased, whether it's sub-meter, sub-foot, or centimeter. When doing GPS, the user would have to go to each sign, each pole, each tree in this example. If you could step back, get good GNSS sky plot, if you will. Back in the day, we'd always check the sky plot. Do I have enough satellites? Do I get good accuracy? And if I do, I can step away a good 10, 20, 30 feet, and then I can actually use that one location and shoot many assets at one time without having to move. So it is time versus money, if you will. You know, can I take the time to do this, walk to each tree, or am I better off just standing in one spot, shooting that tree, that tree, that tree, and collecting my data and syncing my data up to the cloud? And this is just a summation of what we were just talking about. This left slide is an example of what Steve and I were just talking about, where there's a manhole in the middle of the street. This would technically be a 2 or 3 person operation where someone's going to have to flag cars down, or buses, if you will, just to get them to slow down so you could go out there physically in the street, take the GPS shot, when you could step back 20 feet at the curb and do it at a much faster and safe, if you will, workflow. The one in the middle, of course, is the forestry example, or just public trees on a busy street. Best off to stand back, get the GPS offset, and then move on to the next. Similar with the gentleman on the right-hand side there, shooting many assets from one location, and that is possible in all of these apps. Just depends on the laser you're using. If you're using the 360 with the compass, do keep in mind all the variables that Steve had talked about: magnetic interference, magnetic declination, setting that magnetic declination in the app itself, or sorry, not in the app, but in the laser itself. And do make sure that if you are negative or positive, you do have to add that in properly. And there is a website out on NGS's website, and or LaserTech does have it in the user manual, a specific website to go at. You can put in the address of the location you're going to be at, and it will tell you what your magnetic declination is for that specific location. Another thing that reference off of what Steve said is calibrate often, week to week, new job sites, new lat long, wherever you're at. Same thing with the magnetic declination. You're going to have to change that if you move from one state to another, because the magnetic declination is going to swing positive or negative as you go east or west. All right, I will hand this off to Jay, and she'll go over some resources that LaserTech has, and I'll finish up with our resources at the end.
Thanks, Jay. Yeah, I wanted to quickly cover some of the resources that we make available for everyone. We'll start with the websites. We have 2 product pages on our website, one for the 200i and one for the TruPulse 360i. You can see here that we've got a number of tabs along the middle of the page. This is where you find your downloads. This is where you can find the user manual for the 360i, which I've already referenced in the chat for you, as well as the user manual for the 200i. And there are some 2-page brochures that you can find on those that describe, this is more of a marketing material, but it describes a high overview of what each TruPulse does and gives you the specifications that each brings to the table. Additionally, we have a quick reference guide. In the quick reference guide, we cover most of the things that you want to get started quickly in using the TruPulse rangefinders. Additionally, we have a blog post that talks about magnetic hygiene on our website. You can find that in the professional measurement news section. We also have videos on our YouTube channel. You go to @LaserTechPro, you'll see that Derek has been made the star of our videos. We talk a lot about training, how to do things with the different TruPulse units. We're also working on some TruAngle videos as well. So please stop by and take a look. And a reminder, you can find our website at lasertech.com. Our YouTube channel is @LaserTechPro. And we're on social media, and you can also email us directly. The email address is info@lasertech.com.
Thanks, Jay. Yeah, just this last couple slides, just contact information for everybody for LaserTech. You can see here a lot of our marketing team, also our product team, et cetera, that you can get a hold of. Again, these slides will be made available to you guys if you want to contact us. Then I'm going to just go ahead and turn it back over to Jay, but we hope there's some questions to be asked. I have not been able to watch the chat, but we'll take a look at that. And then I'll let Jay from Seiler take the last slide here.
Thank you, Derek. So this is how you can get in contact with us. We do have a toll-free number that you can contact us for any questions having to do with these products that we talked about today. We have a marketing email, mapping@SeilerInst, you can email us at. Otherwise, our support is mapsupport@seilerinst.com and or SeilerGEO, short for geospatial.com. And that will get a hold of our tech support line, which on staff is Andy, Scott, and myself. And we welcome any questions that you have regarding this webinar. But we do have a support website. You can Google it, of course. It's Seiler-MGIS-support, Seiler Mapping Hub. This is where we have all our support material for our DA2s, the R2s, the R580s, FieldMaps, TerraFlex, and also a link to get you to the LaserTech professional page for products and also for support.
Yeah, I got a question for you, Jay.
Yeah.
Like training material, like the actual interface, laser interface with TerraFlex. You've got like work instructions or presentations about that whole workflow, right? Somewhere on your
Yes.
Okay.
We can get customers access to that. Trimble does have write up on that. There are some videos out there on the YouTube channel about that. The beauty of that application, I'm glad you brought that up, it actually will step you through and it will recognize if you have a compass or a non-compass laser, because then it will then prompt you to do either the distance or the Distance-Azimuth, and you will then be asked if you wish to approve or decline and try and run the results again. Something could have happened, trust me, the wind, the pole moved. I like to use the example of you're standing out at the curb and now the UPS truck showed up. Now you have a big metal object in your way that may have either skewed your laser offset shot to begin with, or now is affecting the magnetic compass. Things to think about.
Yep. We've got a question coming through about if there's any advantages of the distance angle method over the distance method. And if you remember that table we showed there, they're pretty close in accuracy. They're both pretty accurate methods. And I guess the differences between them, one of the big ones would be the density of your features that you're shooting. If your features are sparsely populated, like maybe you're doing a front door survey for 911 response, those are fine for the distance. You're kind of just doing one house and you're walking, you're moving your way down. But if you've got a cluster of 10 objects, facilities you've got to map in there, it would be very an inefficient way to do it with that range distance angle would be much better. You set that backside once and then it's just single shot to all those objects. So those would probably be the biggest difference or advantage for that distance angle.
With that distance angle, some apps, are you able to traverse from this position here to get to a new position and then do a backside back to where you moved from? Is that different?
Yeah. For example, our MapSmart app will allow you to do that, kind of carry a traverse. Maybe you've got a bunch of facilities in an underground garage, a covered garage that you need to locate. So you can map underneath there, shoot underneath there with a laser system, and then just carry the traverse through. Maybe you've got to go up a floor to get some objects or something like that. So that's available in that MapSmart app. Yeah.
Okay. I was thinking different applications that apply, and you're able to still move locations. You're not just always just in one spot. So,
Right.
yeah.
See another question coming through about how do you know what target you're hitting when you're measuring with the laser? You want to maybe talk about that, Derek, or different modes we've got and stuff?
Yeah, different modes. You know, we've got you're looking through the laser rangefinder, and you've got this display up here to the right, or up here, and you've got your crosshairs, and you're gonna you know, look right at the crosshairs at that target and press that fire button, and you're gonna see the results right in this display here. You're gonna see your distance result, your inclination result, and if you have a unit that has a compass, it's going to show that result right here too. So it's kind of this 1 point shot, so you're kind of focused on that target itself. But if there's like any vegetation or anything like that, we have these different targeting modes that you can use to make sure you want to get through some vegetation, or want to make sure if there might be, say, if there's a utility pole in front of a building, and you keep thinking you're getting that building measurement. What we can do is a closest mode, and you press and hold the fire button on it, and then you kind of pan back and forth a little bit on the building and then on the utility pole, and it's going to show you the closest target, or the closest measurement. So if you pan back over to the building, it's not going to show you that longer distance. It's always going to show you the closer, or vice versa with farthest. So there's a couple different modes built into the laser rangefinder, or you can have settings to make sure you're hitting the right target. And we've got some different videos on that about these different mode settings and when to use them, and how to use them on some of our YouTube channels.
Yeah, good point. There's another question in there, and if you can find the slide where it shows possibly the DA2, the laser, and the phono mounted. Chad has a question as far as, does it matter what app? The app is not the issue. It's, do you have a 360, compass integrated into the actual, laser? Go back up a couple where you actually showed everything on one pole, Derek. The one that shows basically the DA2, where the battery is, where the laser is, and where the phone is. I think Chad is what Chad's asking about.
Like this one.
Yes.
It's something like similar here. Yeah.
Best practice magnetic hygiene with your equipment, not just the glasses or the keys or the phone you got on you.
This shows the TruAngle setup where you don't really need to worry about the laser being so close to the tablet there. But if you didn't have the TruAngle, you'd want to move that laser up in the middle more, in between the tablet and the GPS antenna, right?
Yeah.
I think you guys you did have a slide where it showed how far away keys or glasses or tablets need to be.
Yeah, we've got that chart.
Yeah, right there. There you go. It's also on the user guide too. There's a section in the user guide, and also you cover this in one of your videos, Derek.
Yeah, we cover it in the video, and we also have some.
There we go. Thanks, Jay.
Yep.
She just put it in the chat.
Guidelines. And also we've got on our facts page a little bit more about the compass, which you need to be aware of. But like the biggest thing is like Steve mentioned, unfortunately, using a TruPulse 360i, you need to move away from your vehicle. You can't be mapping inside your vehicle if it's cold, like you are in Wisconsin. But yeah,
hey, it's balmy. It's in the 40s today. What are you talking about? Shorts weather.
Perfect.
Thanks for attending, everybody.
Yeah, we can sign off here. Thank you, everyone. Thank you, everyone, for attending, and thank you, everyone from LaserTech staff for assisting with this webinar.
You bet. Thank you, Jay.
Yeah.
All right.
Thanks, team.